big long number. Let's do the last letter, letter as a big long number.
Alright, so E. E and natural log. What natural log equations are what's tomorrow?
Calculator has a number E.
What about E?
Does the number E?
Yes. Use X. If you use X, we put easy 1. You should put E. What is E? No, not E. Yep. So it goes like
It's under natural log, ln.
easy. Okay.
Second value.
E to the X equal to 1. Numbers? Yep. Okay. Yep. All right. So usually we use E when we're looking at exponential growth or decay because it's a lot easier to use E than the big long formulas that we're using before because you don't need as much information. So we usually use E when we're using to find the remaining amount of a certain substance that decays exponentially. So instead of something just decaying at the same rate all the time, if it decays exponentially, that means it's either going to decay a whole lot at the beginning and then less and less and less, or much less at the beginning and then more and more and more. So exponential decay or growth. So E is not a variable, E is an irrational number. Irrational meaning it's like pi, it just goes on forever and ever and ever and ever. And yeah, it's found by that series. And usually we round E to 2.7 or 8. But you can use your calculator to figure out exactly, not exactly, but you can use your calculator to figure out the lower decimal places. Alright, so example 1 says, a Swiss entomologist Dr. Paul Mueller was awarded the Nobel Prize in Medicine in 1948 for his work with the pesticide DDT. It was later discovered that DDT presented a risk to humans. Effective January 1st, 1973, the U.S. Environmental Protection Agency banned all uses of DDT. More than 1 times 10 to the 10th kilograms of DDT has been used in the U.S. before the ban. Assume that there were 1.10 to the 9th kilograms of DDT in the environment in 1930 or 1973, and that for DDT, K is equal to a negative 0.0211. So when they're saying K, they mean the constant of how it decays. So this is decay rate. Okay, so they're first asking us to write a function to model the amount of DDT remaining in the environment. So we're going to model it after what we've got at the top. So we're just writing a function. So we don't know how much is remaining. We're using this function to figure out how much is remaining. But how much should we start with in the environment?
See, the 10 to the 9th is going to be the 10 to the 9th.
It's going to be this one. It says assume that there's that how much in the environment.
But it says 10.10 has been used.
Right, but it says assume that we're using this number. Okay, so that's our in prime, which is our starting point. Okay, then we're going to say times e to the kt. So e to the k, they're saying use this number. Notice it's a negative because we know it decays. Times time. And since we're just writing a function to model an amount, we don't know what the time is, we don't know the amount, so we're just leaving in and we're leaving t. We're not going to plug in any numbers for this case.
So what is n to the 0?
N to the 0 is the initial amount. It's what we're starting with.
Why is it to 0?
No, N of 0 just means the starting point. N of 0, like N of 2 would be like of time 2. N of 0 means the starting point. 0 t is okay, so on part B it says find the amount of DDT that will be in the environment in 2050. So we're going to use our lovely function that we set up here to figure out when we have t of what? Are we going to put in 2 or 2050? No. No, we're going to switch it out. Switch out what? Because we're starting from 1973. So what's 2050 minus 1973? 42. So that's our t. So then all we have to do is plug it into our calculators to figure out what n is. I'd be very, very careful when you're plugging in something up here. I put it in parentheses just to make sure you're getting t to. Got it. Okay, which makes sense because we have a smaller number than what we originally started with, because this says to put 9 zeros on after. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be 9. I think it's a million. Yep. So this would be 412 million. So it has decayed by quite a bit, but there's still a line in the environment. Okay, then it says to use your graphing calculator to verify your answer. Do you guys know how to plug in so the y equals?
Anything on my calculator screen.
You can anything on your calculator screen. Should you go into the y equals? Oh, instead of 42, put in your answer.
So the graphing function. Still got nothing. Too small.
I don't know. I think I'm going to it's okay. You don't have to put that. Get it?
It's not on the screen.
Okay, you're gonna just do it quite a bit. I'm gonna set your window maybe. And zoom out.
See.
Alright, so if we were in a big verify, I would go into the table part. And figure out if x is 42.
So next is 42.
You could go into the tables and start at 2. Tables that start at 2.
What do we have to do? 4.12 today.
That's when you double check your answers there. Alright, last thing we're talking about today. Continuously compound interest. So before we were talking,
on page no.
it is on one page.
Hey.
Okay, so earlier we were talking about interest. We were talking about interest being compounded like monthly or quarterly or whatever, weekly sometimes. This is its compounded continuously, so it's compounded every day of every hour of every minute of every second. It's just continuously compounded all the time, so you get more interest. It depends on what kind of account it is. If the bank will do it like this.
It's on verification.
It's on a very, it's not just like a regular savings account thing. They will offer you.
I get like 3 cents in my savings account.
Very nice. Alright, so, notice it looks really similar to this one up here. And actually, it's pretty much exactly the same thing. Because we start with our initial amount. In this case, we call T instead of N0. We have our interest rate times time.
So our initial amount would be 10,000.
It would be. So we're comparing compounded continuously and compounded semi-annually. So we're going to do 2 problems. So compounded continuously, we'll use this one.
2 problems. Why?
Because it says compare compounded continuously and compounded semi-annually.
What's compound semi-annually?
Semi-annually? Well, annually means once a year. Semi means twice a year.
So we're using the same formula?
Nope, we're going to use different ones. Because this one's for compounding continuously. Give me a second. We talked about that earlier, I promise. Alright, so our rate is a 0.0675 times your time of 25.
Okay.
Okay, Miss, you can just leave.
What do we need?
I'm going to send.
Good.
64,000.
1040.
54,000.
1049.
So that was if you compounded continuously, or for another. Alright, if we compound semi-annually, we have to use our other formula, which looks something like A of T, I think is how we said it, is equal to A times 1 plus, I cheated, what should I put first? R over N.
1 plus.
And I guess usually they say this is P. Okay, this is the one that we used earlier back in section 2, I think is when we used it. Okay, so P is still principal, so that's still our
10,000.
10,000. 1 plus our rate.
Whoa.
Oh,
I still got the same answer. That's weird. I got the same answer, but I put in 10, not 10,000.
then your decimal place is going to be in the next line. That's not fair. So compound semi-annually means twice, so 2 times a year. Oops, I forgot this is not N times time. Sorry. So N would be a 2 times 25. Huh? Okay, let's get you there.
Why?
What?
Why is it that why annual and it's 2?
Because semi-annually means twice a year.
It's not that big.
No, not that big of a difference.
Have you taken Dave Ramsey's financial peace class before?
Yeah,
So this is young focus.
52,574 and 62 cents.
So, you're right, it's not that huge of a difference. I mean, about $2,000. So it's a pretty significant money. But it makes sense that this one is more because we're compounding continuously, so we get more interest, and this one you only get interest twice a year. So, here you have things there.
That's not what I have.
What did you, how'd you type it in?
I don't know. I don't know how to type that into my calculator.
Alright, I will first figure out what this is in parentheses.
Yeah.
So I would go 2, add your 1,
Mhm.
and then you're going to carry it, I will put it in parentheses. 2 times 1. Okay, and then I would take it times your.
Okay.
Okay. Alright, any questions on things? No? Alright. I'll write it down. Write it down.
Here's a picture.
What's in our notebook?
Oh dear.
No.
Yes.
I can't.
Okay. Here's the notebook.
I can't read that. There. I can't read it. Hi.
Oh, that's it?
That's it.
Oh, wow.
That one is strong.